Greetings, M squared here, and today we're going to spend a little bit more time on literal equations. So especially this one I wanted to show you because it has an x on both sides of the equation, so we didn't do one like that last time. So remember, our goal is to get one of the variables alone. This is some notation you'll see when you have literal equations. Your literal equation will have a semicolon and then it'll have a variable, and this is not a math symbol, it's just separating the two things. It's just telling you take this equation and solve it for m. So we're going to solve it for m. We're going to get m alone, so we want to ignore this for a minute and get rid of this. It just makes it much easier, because if you wanted to, you could divide everything by -6, but then you have a bunch of fractions. You have negative 2/3 and a positive 1/3, and then it's just a little more confusing. So it's always better, in my opinion, to get rid of this first. So how do I get rid of a plus 4n? I subtract 4n from both sides. So I'm going to do that. I'm going to get negative 6m equals negative 4n minus 2, and then just need one more step to get rid of my -6, which is a coefficient. It's being multiplied, so to get rid of multiplication, I divide, and I get m equals negative 4n minus 2 over -6. Now, this is the answer, but it's not considered simplified. So there's two ways you can look at it. You could split it up into two fractions, like that, and you could simplify them, get 2/3 n minus 1/3, plus. Everything's negative, so it's going to change. Negative divided by a negative is a positive. So this is an answer. Or you could just simplify it here. You could say, oh, everything that's negative divided by negative is a positive, and then 2 goes into 4 2 times, 2 goes into there 1 time, and 2 goes into there 3 times. So either one of these answers is correct. It's up to you on which one you like. If you like one fraction or if you like two separate fractions. Either one should be fine. Over here we see that there's x on both sides. So you can't solve for x. You can't say, oh, x is already alone. It's all by itself on one side. You can't say that if there's another x in it. It's like defining a word using the definition of using the word in the definition. We don't want to do that. So we're going to use distributive property. That means we get negative 3x minus 3n. And now we need to get all our x's on one side, because in order for us to get x alone, they'd all have to be on one side. So we're going to add 3x to both sides. Negative 3n equals 4x. And now I just have one x term, so I just need to get rid of its coefficient. So we're going to divide by 4. X equals negative 3/4 n, or negative 3n over 4. Again, those are the same. Okay, now I wanted to do a word problem with you where we're going to use this information. Let me try to zoom in a little bit. So you see we have some cans here, some beans, some soup, some corn, some tuna. Manufacturers often want to maximize or minimize things. They want to minimize cost. In this case, they want to maximize the volume, what they can put in, while minimizing the amount of metal that they use to make these cans. Because minimizing the metal will help save them money. And so they have decided that this formula right here is what will work to maximize volume and minimize the amount of metal used. So it's our job to use this formula. You see it has several variables, the r and the h, and that way that means it's a literal equation, sorry. And so they're asking us, this was just an explanation, they're asking us to solve for h. So we need to get h alone. So we're going to take 2 pi r cubed and pi r squared h and solve for h. Now how we do that is really nice and easy. It looks a lot more complicated than it is, because these are all being multiplied together. And so there's only one thing that gets rid of multiplication, it's division. So we're going to divide by pi r squared on both sides. And that gets rid of that coefficient of h and leaves us with h. Here we can do some reducing though. Pi divided by pi is 1. R squared goes into r cubed r times. Now, if you had forgotten the rule The exponent rule when you're dividing is if the base is the same, subtract the exponents. 3 minus 2 is 1, so our new exponent would be 1. But if you forgot that rule, it's really easy to just ask yourself, well, what does r cubed mean? What does r squared mean? R cubed means r times r times r. R squared means r times r. And so we would know that r divided by r would cancel out, and we'd be left with an r. So it's really a lot of times easy to figure out the exponent rule if you just think back to what they mean. So now we have h equals 2r. We have gotten h all by itself. And then they said, well, how is the height related to the radius for a can that meets this goal that they set up, that little equation? Well, how is the radius and the height related? It looks to me like the height is 2 times the radius. So the radius is half the height, and the height is twice as big as the radius. So we would just write that. The height is 2 times the radius. Okay, we're going to use this information down here. So then it asks us, it says the area of the label of the can is 2 pi RH. Use your result from part A. What was part A? The 2r equals h. To write a formula giving the area of the label for a can that meets this goal. The can that meets this goal is one where the height is 2 times the radius. So what I can do is I can come back up here and I can take out h and put 2r in. So 2 pi r times h, but instead of h, I'm substituting 2r because that would meet the manufacturer's goal. And then I simplify. What's 2 times 2? 4. R times r is r squared, and then I have pi. So 4r squared pi, or you could also have written it 4 pi r squared. Either one works. But that is the little formula that would help us maximize our volume and minimize our metal. Alrighty. Good luck with those literal equations. M squared, signing out.